Yeah, can someone quickly summarize what we have discussed in our last session?
Um, we have discussed about the abstract class. Um, so in the abstract class, we cannot instantiate or cannot create object of the class. And similar way we cannot similar way for the method in the abstract class. For example, if we have like a animal, then animal as a parent class and subclasses as a animal as a parent class and subclasses, then for example make noise as a method, then we cannot create it doesn't make sense to create a make noise method as a make noise method because each and every subclasses will have different method. So what we do is we just create a abstract method instead of just um, instead we just declare the method in the abstract class. And in the child class we have to implement each of the inherited abstract class. That we do by annotation @override. And what else? Yeah, one of the reason why we do why we if we don't put like abstract class, we can like still print print out the we can still make the program work. But why we do it is because to it enforces and organize every subclasses, every enforces and organize the program. For example, if we want to create a new animal, then new animal subclass, then all the animal subclass has to have like the age, name, or the make noise method of the parent class. We also talked about multi-level and hierarchical method of inheritance. In multi-level, one class, the derived class can be extended. For example, like if there is a grandchild, can be derived from like my child, and my child can be derived from my class. So another one is hierarchical, one in which one class serve as a parent class and the rest of the class are the child class.
Okay. Yeah. Yeah. Thank you for that, Rasha. Right. I mean, I think that's exactly what we have discussed. We basically started by in our class before we stopped it till single inheritance. So yesterday we saw other approaches of multi-level inheritance and hierarchical inheritance, how they work basically, and then we also understood runtime polymorphism in detail, right? We were talking about different types of polymorphism, which is the compile time and runtime. And compile time is called as method overloading, and runtime polymorphism is called as method overriding, which comes in perspective of inheritance, where your superclass or parent class contains a certain method and you are overriding that method change behavior. You're basically providing additional implementation, changing the behavior of your that particular method in your subclass, right? And at the runtime, right, when you're executing your Java program, based on the reference you are providing and the object you are initializing, it will try to call appropriate method in the either your parent class or child class. And this is resolved at, since this is resolved at a runtime, this is called runtime polymorphism. So in case of method overriding, we see the runtime polymorphism aspect, right? And yeah, and then we went on discussing about multi-level and hierarchical inheritance. Then we spoke about abstract class, right? So basically a class which contains methods which are which doesn't have any implementation, right? So then they are called abstract methods. So when you make a method abstract, your class would automatically become abstract, and we definitely can't instantiate abstract classes because they are incomplete, right? So normally in a scenario where we tend to enforce certain restrictions on our subclasses, right, and we make use of the abstract class, right, like where if your subclasses have to override certain method for sure, right, and provide implementation for it, you want to enforce our child classes to do that, then in that scenario you can have an abstract class which will contain some abstract method. So your child classes, whatever extending the abstract parent class, should definitely provide some implementation for the all the unimplemented abstract methods in your abstract class, right? And we use this keyword abstract. And the another important point we focus in Java, any class can extend at max only one class, right? We can't extend two classes at the same time. That's the reason your multiple inheritance and hybrid inheritance are not possible in Java. Okay. Whenever someone normally in interviews they ask you, is multiple inheritance possible? No, right? So in when we talked about inheritance, see, in interfaces it is partially possible, but we shouldn't call it as multiple inheritance, because when we talk about inheritance, we are basically talking about state of a certain object, right? So your class basically contains state, which is the data, right? But your interfaces, they are not supposed to contain state of any real world entity or object, right? So we just don't consider whatever thing that can be doable as a multiple inheritance. Okay. So in interviews, people tend to ask you this question, why multiple inheritance is not possible. You can tell them about this diamond problem, right? Which is nothing but basically you have a same method in both parent classes. When your subclass overrided, which method in your both subclasses it would override, like that would be an ambiguity, right? So that's the reason we will not support multiple inheritance, right? Now, okay. Having said that, today we're going to talk about interfaces. The next important construct in your Java programming language, right? And again, coming back to how can we, what is abstraction again? One of the object-oriented principles. What is abstraction? What is abstraction, guys? If you are a Java programmer, right? Day in, day out, anytime someone asks you about object-oriented principles, you should be able to tell it, right? What is an abstraction?
It is one of the process that hides the complexity of the application and only shows the related relevant attribute of an object.
Recording it.
Right. Thank you for that. That's right. So in Java, how we can achieve abstraction?
To extend the object class, abstract class or method.
Yes, one is using the abstract classes and the next one is using interfaces. Okay.
Interface.
So both abstract class and interfaces, they will have empty methods. They don't have methods with some implementations. Okay. Whatever classes that extend abstract class or implement an interface should be will be having the actual implementation or complexity involved within those classes. Okay. But whenever we try to access certain methods, we access through them interfaces and abstract classes because of the runtime polymorphism support. Okay, that way we are achieving the abstraction in our applications, right? That's how we adhere to the object-oriented principles in our application, right? Having said that, yeah. Having said that, I want to let's talk about interfaces, right? So till now you saw different constructs in Java, like classes, right? So I'll just put a slight comparison of everything here. We have classes, and then yesterday we came across abstract classes, and then we're going to talk about interfaces. So how the classes would look like? It starts with class keyword, right? And the syntax would contain we can be object, or we can say can be instantiated, right? We can instantiate a class. Yes or no? Is my screen share visible here?
Yes.
So my class can be instantiated. That means an object can be created. And how my class will look like in general? It will start with the class keyword, name of the class, right? And then it would contain the type and variable name, right? Variable name. It will contain so many types, so many, it can contain one or many or none variables. And then again, it will contain type, method name, some arguments list, and some implementation list, right? And next to abstract class, we use this keyword abstract, right? And at the same time, these cannot be inched, can't be.
Sir, there?
Hello?
Yes, sir.
Okay, thanks guys. I think there was some problem with my Wi-Fi. Got disconnected. Guys who are joined late, like Raj, TS, can you all just join with proper names, like your full names? Fine. Okay, let's start. So where are we? We were talking. I was just putting the differences between everything, right? And we know that abstract classes we can't instantiate, right? And if we look at the typical syntax, it would contain something like this: abstract class name, right? And it would contain the same thing, right? Same thing, but in addition to this, it would contain the same type name, and it also contains the similar method. But in addition to this, in addition to this, it can contain some methods which have type. These are methods which have some argument list, but they won't have any implementation. They are just abstract. So to indicate that, we use this keyword abstract in front of those methods, right? This is the basic difference between the class and abstract class. Now coming to interfaces, right? Here we use the keyword interface. And here they also can't be instantiated. And how we create an interface using this interface keyword. Interface name and some variables. Hello, am I audible, guys?
Yes.
Yes.
And there was a problem. Okay. So this is the difference with respect to interface, right? In interface, everything is an abstract. Like you won't have any methods that will have some implementation of some body like this. In interface, everything is just a declaration. Like every method in interface is by default an abstract. So we don't need to put a keyword like abstract in front of this. Okay. So this is how interface look like on a structural level. So I hope you guys are with me, right? Or should I know there has been, I got disconnected a couple of times, but are you guys, did you guys understood what I'm trying to say? I'm just trying to chart out the difference between classes, abstract classes, and interfaces. Is it clear?
Can you explain one more time?
Okay, sure. So if we look at classes, right? Classes, we use the keyword class, and then we can instantiate class. If you look at a normal construct or syntax of a class, it would start with class, it would have a name, and then it would contain some variables, right? And it would have some types like integer, short, byte, and all. And similarly, it would have also some methods which would contain some return type like integer and sort of, and then the name of your method, and it would contain some arguments, and it would contain some implementation. Okay, like this, it would contain some implementation. Okay, and this is how a basic structure of a class would look like. It can be, we can instantiate a class. That means we can create objects from our class. Whereas in case of abstract classes, there say everything is same as class, but only thing is they can contain some methods which will not have any implementation like this. Here you have an implementation, right? So here abstract class can also contain methods which will have some implementation, but at the same time it can contain methods which doesn't have any implementation. We call them as abstract methods. When you name your method as abstract, if your class contains one abstract method, then your class automatically becomes an abstract class. And when you have unfinished classes like this, because of this unfinished abstract methods, unimplemented abstract methods, you cannot instantiate them. That means you cannot create an object, right? So, and you use the keyword abstract, right? This is the key difference between class and abstract classes. Now coming to interfaces, in interface also you can contain variables and methods, but the catch here is, in abstract classes you can contain, you can have abstract methods which doesn't have any implementation, and at the same time you can also put methods which have some implementation. In abstract class you can have both, but in case of interfaces it would contain the methods which doesn't have any implementation. Okay, so that means all your methods in interfaces are always abstract. That means that doesn't have any implementation. Like, abstract is a combination of abstract and implemented methods, right? Whereas your interfaces, all methods are always abstract. Your interfaces won't contain methods that have some sort of implementation. Okay, but this has been changed in Java 8. So in terms of prior to Java 8, in Java 8, people introduced default and static methods. We'll discuss them when we talk about Java 8 futures, okay? But at this moment, in that your interfaces doesn't contain any methods that will have some implementation. All methods in interfaces are always abstract. So that's the reason, again, you can't instantiate your interface. That means you cannot create an object of your interface. So object is something that related purely to class, okay? And understood? This is the key difference between them. Understood? Any queries now?
Why do we like? Why do we? When do we use abstract class, or I mean, or the interface? Like, what kind of cases?
That's a very good question, and it's a question that's asked in many interviews. Okay, they just ask you the difference between abstract class and interfaces, and they'll ask you why I can't use this, why I can't use that, and all. Okay, we will discuss that for sure. Okay, just a little more time, we'll discuss that. Okay, so having said that, have you understood like what exactly is the difference between class, abstract class, and interface? How they look like? Is it clear, or any doubts? I'll come to that point in what context we use one over the other, right?
So interface looks similar to abstract class. I mean, it looks exactly the same, but only difference is some syntax differences.
No, there is a difference, right? Abstract class can have a method which will have some implementation. Interface cannot have. All methods in interface are always abstract. That is, they are unimplemented.
So abstract class can have implementation, or they can have abstract class which doesn't have an implementation, but the interface just have methods that doesn't have implementation at all.
Right. Classes, every method will have implementation. Interfaces, every method won't have any implementation. Abstract, it can contain methods that have implementation and no implementation also. Both is possible.
Yes.
Okay. But both abstract classes and interfaces are used to achieve abstraction, to implement object-oriented principles of abstraction in our applications, Java programs. We use both interfaces and abstract classes. Both are used for the purpose. Okay, because both cannot be instantiated, right? Both abstract class and interfaces, we cannot create objects. Both act as a contract of your application. Like, they both manage the complexity. They both hide unimplement, details which shouldn't be focused by an end user, right? They hide your complexity of a system. Okay, and is it clear? So the difference is clear. Then I will talk about the next aspects. So basically, like I said, right, abstraction is managing complexity. How we manage? By hiding the internal implementation and only showing basically what is needed, right? Like no need to worry about how it works and all, right? That is the principle of abstraction, and we can achieve that using both abstract class and interface, right? Now, if we specifically talk about the few other, I'll talk about this is a high level difference. Can I talk about more points? Is it clear? If you're clear, I'll go into more points.
Yes.
That's clear.
Okay. So starting with, right, if you look at the abstract classes, right, the methods which you implemented, right, in class, these variables and these methods, they can be public, private, protected, default, anything, right? In class, anything is fine. These variables can be private, public, protected, anything. But in case of abstract class, the same is true with the variables and this methods which are implemented. But methods which are not implemented, they should be always what? Public. Because there doesn't have any meaning, right? Until and unless they are implemented by someone. So this method should be always accessible to the outside world to implement it, right? That's why they should be always public. Okay, understood? And these variables can be integer, anything and all. Here it can have normal variables, it can have static variables, right? And it can also have other type of variables also, like it can have final variables. Okay, you know static and final, right? Same goes to abstract class also. Here also it can have static variables and final variables, but whereas in interface, every variable by default present in interface is static and final. Okay, understood, right? I mean, what I meant to say, it's static or final. In interface, all variables are by default final. Okay, or else, or it can also contain static. If you don't mention any type, it will be final, or else they can contain a static. No, I think it cannot contain static variables. I think abstract class. No, yeah, it can contain final variables, static variables also interface. Okay, this is another difference. And like I said, everything in interface, everything is public by default. You cannot private methods or private variables in interface. Remember this. Okay, because everything interface itself doesn't have any meaning unless and until someone implements this interface, right, and provide some implementation for it. Okay, understood, right?
So we can extend interface also. I mean,
Yes, that's a good question. That's where I'm coming next. Like, let's create one interface, sample interface. Okay, I'll say, you can see, right, new interface. I'll name this interface as hello first. Probably the name hello already used. Right? Probably I'll say, oh, test is also there. I think, yeah, test interface. Now, if you see this public interface test, right, I can put one method here, like say void. I don't want to return anything. Void all. We can put some method like all. That's it. So, void all. That's it. This is our interface. Okay. Very simple interface. But
We don't need to implement.
Yeah, your interface doesn't stand any meaning, right? It should be implemented by some class end of the day. So you can call this as test IMPL, some other class, and here we will use this implements keyword. Okay, and we will put the name of test. So that means my test IMPL is implementing test interface. Now, if you look at the other, it will ask you to add unimplemented methods. Now I have to override and provide some meaningful information for this call method. Okay, here I'll just this out. I am interface method. Understood, right? The difference here. So you have your test interface, and here I'm using this implements keyword of your to to provide the implementation of its unimplemented methods like this. Okay. Suppose if you add another method tomorrow, right? Void push method, for example, right? Then for that also, you guys, are you able to listen to me?
Yeah.
Sorry guys, I think I don't know. There are a lot of Wi-Fi issues today for me. Really sorry about that, but please just bear with me for today. Okay. Yeah. Now we have this another interface test2 we created, and it has pop method. Okay. Now my class test_impl, it can also implement multiple interfaces like this. Okay. Add an implementer pop, right? But in case of inheritance, can we extend multiple classes?
No.
No, right? But this is possible. Okay. When you have to implement interfaces, and you can implement multiple interface, right? Now there is another catch also. I'll remove this test2. Okay. And I can actually, okay, I'll put this test2. I can extend my test2 interface, extends, right? I can extend test interface like this. You understood, right? I am implementing only test2 interface. My test2 interface is extending. My test2 interface is extending test interface. So that means my test2 interface will contain pop method, call and push. Everything will be here, right? Automatically when I extend it. I don't need to like put it again. So these methods are already available here. So that's why when I implement a test2 interface, I have to implement call and push also, because test2 is extending test interface and test2 is containing the call and push methods. Like if I remove them, again it will throw a compilation error saying add unimplemented methods. Okay, call, push, pop. Understood, right? So I'll just quickly summarize it here again. Okay. Now that we have classes and interfaces and all, right, a class can extend only one class, right? This is something we know. One class. Okay. Now a class can implement multiple interfaces. Can we say that? I'm making some statement. Just tell me whether they are correct or not. Can we say this? A class can implement multiple interfaces?
No, just one. But interface can do that.
I just saw this. We just saw this, right? Test2, and I was putting test also here. Like this. This is correct. A class can implement multiple interfaces. Okay, but it can extend only one class. Test2 and test are interfaces, right? So I can do this way. Understood?
Yeah.
Is it clear? Asha. Now a class. Okay. Now I'll take abstract class. Okay. An abstract class. This should be an abstract class can extend only one class. Is this statement true? Can abstract class extend another class? As
No.
or no?
No.
Hmm?
One at a time, one class, and one. No.
See, when you talk about extend, it is possible only with one class. Okay. Multiple classes, don't even think about it. It's not possible. But can abstract class extend another class? Think. Okay, let's give it a try here now. We created one abstract class the other day, right? This is an abstract class, right? Close. And I have another class C here, which is extending A. I have A, which is extending A. Okay, I have different classes like this. Now I'm going to create a new class. 𝐴𝐵𝐶𝐷𝐸𝐹 class. Okay. I will create one more class, FG class, and I'll make this G class abstract. Okay. Now let's see. Now what is our what is the statement we are trying to verify? We want to check if abstract class can extend one class.
Another
Right?
class.
So that means abstract class A here. I'll put extends keyword and I will put F. Yes, it is possible, right? So this statement is true. Now, an abstract class, can it implement interfaces? What do you think is the answer? What do you think is the answer? I think we have test interface, right? This interface. Test. Can it implement it?
Yes, we did, I think, test class and test.
Sorry, come again. Implement. Okay, test. Yes, it can implement test, but it is not forcing in case of class, right? It will force you to put this unimplemented override like this, but in abstract classes, it is not forcing this interface to put the call and push methods. Is it forcing? Because abstract class can also contain unimplemented methods. Okay, just remember the difference between when you put in a class, when your class is extending the test interface, you have to override these methods, both call and push methods, which are there, right? You have to override and provide some implementation for it when your class implements an interface. But whereas in case of when abstract class is implementing an interface, you no need to override them, because your abstract class can also contain abstract methods, unimplemented methods like interface, right? In interface, I told you all methods are by default abstract. So that's why no need to put an abstract keyword in front of the methods. Okay. Since abstract classes contain both of these, so you have to put it. Okay. Next we'll talk about an interface. An interface can extend. Can interface extend an interface? What do you guys think? An interface can extend class. One class, or it can extend normal class, or your abstract class can also extend an abstract class. Okay. And here is also same. A class can extend normal class, or it can extend an abstract class. Okay. So what about here? An interface, can it extend class or abstract class? What do you guys think? This is really important, guys. If you don't know this difference, you will not be able to design any application when you develop. Okay. So you have to be really clear with these statements. Okay. When you understand this, then you will automatically know difference between abstract classes and interfaces and classes. Then when you design your system, you will select the appropriate one, whether abstract class or interface or what you should select. Then you can automatically make that decision. Now tell me. Just give it yes or no. Just give some answer, right? At least I know you guys are thinking something.
I think no.
No. Okay. No, is it? Okay. Anyone else think this is possible? Any of answers? Yes, this is obviously no. Okay. An interface can't extend class or abstract class. Okay. Because your interface is always incomplete and we cannot even create an object for it. So what's the point of extending a class and abstract class? Even here, your abstract class, even though it's extending class, it can extend, but at the same time, we can't instantiate. So at the end of the day, if you want to make use of this, again, another class should extend this abstract class. That way it will be useful here. But here, there is no point, right? When interface is extending class and abstract class, they may contain methods, they may contain proper methods, right, which have some implementation. So there is no point here. So this is not possible, but this is possible. Okay? This is quite possible. But understood, right? An interface can extend only one interface. This is possible. Okay. Let's just quickly see that. Okay. You have a test interface and you have a test2 interface, right? Now I'm going to create another test3 interface. Okay. So my question is here, an interface can extend only one or can it extend multiple interfaces? This is my question now. What do you guys think? Can my test2 extend test and also can it extend test3 at the same time?
Yes.
What do you guys think? Yes or no?
Yeah, the classic can do once and this one.
We are
Yes.
not providing any
Yeah,
implementations.
it's more than one or more than two.
So
As
an
many as
interface
you
can
want.
extend multiple interfaces. Okay. And now an interface, can it implement an interface? An interface, can it implement an interface?
Yes.
One or multiple, anything? Yes, is it? Who said it? Rajan. Okay. Yes or no? What is the second? Okay, someone said yes. Anyone else thinks no? An interface, can it implement another interface?
Oh, the implement? No, it's no. Sorry, I thought it's extend.
Right. When you implement, you have to provide the definition for that interface, no? But your interface is supposed to
Right.
contain unimplemented methods, abstract methods. So this is not at all possible. Okay. Understood, right? So take these statements, guys. Just read it, check them. Okay. These are really important. You can call them as Bible to decide between all these statements are pretty important. Okay. So based on this, you can decide whether you should choose abstract class or interface or when designing something, right? So like if you Google and just try to check the difference between abstract classes, even when they ask you in interviews, you can tell these points, and at the same time you should also tell that the variables that can be abstract can be normal variables or can be static or can be final. But in case of interfaces, we can either have static or final variables. By default, all variables in interface are final. Okay, you cannot have a normal variables in interface. That's one key aspect. Okay, now if they specifically ask you what should be the scenario where you will use and all, right? Now to do this, we have to think in a sort of a reverse way. Okay, reverse way in the sense, suppose let's assume you have one abstract class and you have a class. So your class is basically extending that abstract class, right? So when it does that, any unimplemented methods in abstract class, it should provide it. It should provide some implementation for it, right? Yes or no? Yes or no, guys? It should provide, right? If it contains, if a class extends extends an abstract class, and then abstract class contains some unimplemented methods. Did I guys lost you? Have you guys understood my question?
Yes, sir.
Okay. See, normally, if we talk about a particular scenario in case of like when normally people ask you, like when will you use abstract classes or when will you use interfaces, like Vasha or Asha, someone asked just some time back, right? Like uh, when we talk about objects which are kind of related, right? Well, like when you design a system, like if you see there are multiple classes that are related to each other, right? And you want to provide, you want to have some common functionality. If there is some common functionality across all these classes, for example, or all these objects, right? Then you can create one abstract class and provide implementation there. Understood, right? And you can make these classes extend that abstract class. So that way you are removing the common behavior across multiple and you're putting into an abstract class, right? By providing that feasibility, your objects can reuse that implementation of your abstract class, or they can also override that implementation, and they can, your class subclasses can have their own implementation as well. Okay, that's one key difference. But in interfaces, they are kind of they also provide common functionality, like whatever class that implements interfaces should definitely implement that, right? But they don't have some default functionality or default implementation, like like how we can specify with an abstract class, right? So the key difference is this one, and you can tell that the modifiers and basically the methods and fields, right? In abstract classes we don't have any restrictions, right? Whereas in interfaces you have restrictions that they should be public by default and they should be final and static, right? So based on these use cases you can decide at certain, like based on, so probably I will pick some real-time example and explain in detail when I talk about Java 8 features, because in Java, from Java 8, the interfaces are also started to contain methods which are not abstract, like which contain some default implementation, like for example default method and static methods which are introduced in Java 8. Okay, just remember this. In Java 8, Java introduced default and static methods in interface, so which would contain some implementation like this. So I will, like I said, I'll discuss this when I talk about Java 8 concepts, and there we will spend good amount of time understanding between abstract classes and interfaces again. Okay, so there I'll give you some real world example, so that would help you to understand this better. Okay, any questions, guys? Okay, so the next thing we are going to talk about is exception handling. Okay, so like take your Java applications, right? They may execute fine properly, and at some point of time some error can happen, right, within your application, and then your application execution may suddenly halt, right? Or and your application stops functioning, right? So that means your application had some error, some problem in it, right? So likewise, there are we are basically using different programming constructs, and they can also cause certain errors and certain exceptions when they execute. I mean, depending on the data they're working, they may behave a bit differently, right? So there are certain exceptions that you will get generated, right? So basically you can think an exception as like an abnormal condition when your JVM basically executes your code line by line, right, at runtime. It may execute some abnormal condition, and that is nothing but exceptions in Java, right? So you can think Java exceptions as a, you can think exception itself is another class. So basically an exception is object in Java. Okay, right? So a Java exception, you can think of it as an object which basically describes an exceptional condition or like an error condition which occurred in a piece of code, right? And when this particular exception condition arises in your code, an object representing that condition, right? The error exception is basically thrown in the method, whatever is that is basically causing that error, right? And at that point, we may choose to handle that exception or we may pass it. So that way we can avoid the complete halt of our application. Like if you don't handle or throw or catch your exceptions, right, and handle them, your application would stop immediately when it executes something and when it basically executes something. Okay, now I'll just give you some examples of what exception is to get a better understanding. Okay, so I'll just close this. Okay, I'll take exception demo. Okay, to understand this, let's start by taking an array. Okay, array of I do. Okay, so we basically have an integer array. What is the size of this array, guys?
3.
Right? Okay. Size of this array is 3. That means I can insert 3 elements, right?
Yeah,
A
0, 1.
equal to 1, I can say 10. A equal to 2, I'll say 20. And A equal to 3, I'll say 30.
It's 0, 1, 2, 3 or just 1, 2, 3 in this time.
Yes, actually it's 0, 1, 2, 3. But let's assume I gave it this way. Okay. And I'm executing this program. Some beginner mistake, some beginner programmer or someone might have done this mistake. Okay, ideally your index starts with 0, 1, 2. So if you have size as 3, what would be the max index possible?
2.
2, right? If you have size as 3, the max index possible is 2 because you started 0, 1, 2, 3 in case of indexes. But assume some new programmer kind of took it this way, A of 3 equal to 30. Actually, in this array, the max index available is only 2, but he is trying to put some element at index 3, which is obviously not there. How your code will behave now?
We use try and catch. Or...
Now, if you see at 11th, 𝑒demo.java11, at 11th line, you 𝑒demo11, at line number 11th, it throw an exception may Java lang array index out of bounds exception. Look at the exception, array index out of bounds, index 3 out of bounds for length 3. Does this statement sounds meaningful? Because the max index that is possible is 2, but we are trying to access third index. So that's why your Java program is not working as expected. It is behaving, it is throwing an exception. This is called exception. Something that is abnormal in our code sequence is referred to an exception. So when you get this exception, our application will terminate abruptly. Because let's see here. Hello. Will this hello get printed or not? Tell me, will that hello will get printed or not? Yes.
Yes.
Are you guys sure, guys, it will get printed?
There's a elements in there, so 3.
It will not get printed, right?
It won't.
Because
It won't.
here it's an abnormal condition. So your program fails here. It will not go further, right? It's like your program is completely blocked. It will stop its execution then and there immediately. Understood, right? It will not even execute anything after the line, and at this particular line, Java line. Okay, here it caused an exception, so it will not go beyond this line. So all the code that you write after that is of no use. It will not get executed at all. Okay, is this something desirable when we develop our applications? Is this something desirable? Suppose let's assume you're updating, you're doing some transaction. Okay, you're deducting money from someone and your bank is supposed to deposit in someone's account, right? So when you are transferring, sometimes I think you might have already faced, right? On that payment gateway, your amount may be deducted from your end, but on the other to the merchant website, it may not, the transaction may not complete, and sometimes your money is stuck in the middle, right? Yes or no? Can't we treat it as an exception scenario? Can we treat that as an exception scenario? Are you guys following me?
Sorry, what is your question
Yeah.
again?
Yeah, we can do.
You are buying something on Amazon, okay? And by using your Amex Visa card, for example, right? And it was some $1 amount. You paid the money, and but you went to cart, you did checkout, and you paid the money, but it didn't reflected back into Amazon website. Okay, something failed in between because of some network error or something. The transaction was not complete. So what will happen there? Your amount would be debited from your Amex account, right? Bank account, but and at the same time it will not reflect at the Amazon end. That's your payment is paid or not. It will still say payment failed or something, right? Is this a desirable behavior?
Yes, it's exception.
No.
It's an exception. So what does people do? What does the system does in these kind of scenarios? How they will
We
mitigate this
put the
problem?
exception
Yes,
handling.
this is an exception scenario, right? Yeah, I mean, let's not get into technical. We'll just talk about in common terms, right? General terms. So how your system will mitigate this problem? How in general sense, let's talk about, right? You're facing some problem like this, right? And what sort of resolution you expect here? You would expect whatever funds that got deducted to be immediately credited or refunded back to your account, right? Yes or no? That's what happens also, right? When you're making payments, if it got broken or failed in middle because of some issue, for a brief moment of time, those funds are deducted from your account, and after some time, the system will automatically verify and it will say the transaction wasn't not complete, so it would credit you or refund you back that amount. Yes or no?
Yes.
Something like yes or no? Yes, right?
Yeah.
So that is not the first phase. You are in an exception, and now you handle that exception successfully. So that way your system is consistent, it's performing properly, right? So see, in real world Java, nobody can write programs which are not exception free. Okay, because your programs behave differently because of the data. End of the day, all your programs has to work with some data. Yes or no? It needs some data, right? And users gives that data. So there can be some set of data because of which your program may went into an exception state and it will stop some execution because your program doesn't know when it gets some input. It may get some input which is unexpected. So it will be an exception state. having exception state is inevitable, but as a programmer, we should be able to guess that exception and we should be able to handle it. Okay. So in this scenario, right, I will handle using a try catch block like this. I'm just writing this for now. Don't think too much. Okay. Just look at it for now. Tomorrow we will discuss this in detail. Again, okay. I will say exception E. Okay, like this. So now I am handling my exception. Now tell me, will hello get printed now or not?
It will.
It will print.
It will print because there I handled my exception. Okay, I tried to do something meaningful there. So now my system is not broken. I handled that abnormal situation in my code and I was able to, execute my application properly without any abnormality of, stopping it in between. Okay, so as a programmer, we should know which sort of code may arise some exception and we should know where we should try to handle exceptions in Java. So that's what exception handling in Java is about. Okay, so tomorrow we will talk this in detail, guys. Just sync this concept for now. Okay, and tomorrow we'll just discuss this at length. Okay, we'll stop here. Any questions, guys? I'll just take any questions if you have for a few minutes.